Hello! Today we're going to be looking at the Lesson 4 problem set. For each equation, decide if it is always true or never true. So in order to do that, we're going to just solve these. I'm going to move all of my variables to the same side. In this case, they cancel, and I'm left with negative 13 equals 1, which is never true. Working on the settings a little bit here. Okay, next we have problem B. Put never true there. 1/2 equals negative 1/2. Never true. So I've written the never true here. I feel like I'm going to do a little more space for the next one, so I'm just going to bring it over here. I'm going to distribute and get 2x plus 6 equals, I'm going to combine my like terms here. 5x minus 3x is 2x plus 6. And I can already see these are exactly the same. Just to double check, I will keep going. And 6 is 6. That is always true. Moving on to the next one. Looks like I have some like terms to combine again. So maybe I can write it beside of it. X minus 3 equals 2x minus x is x minus 3. And I'm going to subtract x from each side. Negative 3 equals negative 3. And that is always true. One more on this question. We have 3x minus 15 equals 2x minus 10 plus x, which would be, when I combine like terms, 3x minus 15 equals 3x minus 10. Subtract 3x from each side. Negative 10 equals negative 10. Not true. So, that is never true. Next question. Mia says the equation 2x plus 2 equals x plus 1 has no solution because the left-hand side is double the right-hand side. Do you agree with Mia? So, let's go ahead and just copy this and we can write it down. Let's solve for x. That would leave me with x plus 2 equals 1. Then I could subtract 2 from either side. Run out of room. X equals negative 1. So in this situation, there actually is a solution. As I'm solving, I end up with x equals a number. Whereas up here, it's almost like the x's canceled each other out, and I ended up with numbers that were either the same as each other, which is always true, or different than each other, which is never true. So this is different because I have a variable on one side, and that is equal to a number. So that means, no, we do not agree with Mia. And we've just talked about the why. This actually has one solution. One unique solution, which is x equals negative 1. Okay, I'm not going to include these next two questions as part of your problem set on Canvas, but I am going to discuss them. So if I want this to be true for all values, what needs to happen is I need something equal to this. So I'm just going to distribute and get 3x minus 5 minus x, which this is one solution that I could have, or I could go ahead and combine my like terms, 2x minus 5. In other words, anything that is equal to 2x minus 5 would be, could be used so that this is always true. And to make it so that it's true for no values, it has to be an expression that is not equal to 2x minus 5, which is the simplified version of this expression. So as long as it's an expression that's not equal to 2x minus 5, then it would make it true for no values or never true. Moving on to question E. Here's an equation that's true for all values. So it says this is true for all values of x. Okay, and I can see they've distributed the 5 in this expression to get this equivalent expression. Now Elena saw this equation and said she can tell that is also true for any value of x. How can she tell? So it looks like what she's done is multiplied everything by 4, because she did 5 times 4 to get 20, and then just multiplied this quantity by 4, and then she's also added 31 to each side. So she's added and multiplied by the same thing. Let's go ahead and just simplify this to prove to ourselves that it is equivalent. Okay, so 20x plus 40 plus 31 would be 20x plus 71, and this would be 20x plus 40 plus 31. So that's 20x plus 71. And then I could subtract 20x from each side of this equation, leaving me with 71 is 71. So let's see. Elena saw the equation. She can tell this is true. And it's true because what she did was multiply each side of this equation by the same value, and that is how we keep equations balanced. So that works. For this question, I am needing to describe the change that each person made to each side of the equation. So if I look at Elena's work, I can see that 1/2 x is no longer on this left side. And then over here I see that there's an addition of negative 1/2 x or minus 1/2 x. So that lets me know that she subtracted 1/2 x from each side of the equation. And then I'm going to look at Lynn. So it looks like somehow we went from 1/2 x to x, and then we went from 3 to 6, from 7/2 to 7, and then from 5 to 10. So there's two ways you can think about this. You can think, oh, it looks like everything is multiplied by 2, or another way of thinking of that would be everything is divided by 1/2 on each side of the equation. Okay, so then we have some just equations to solve, a few of those. So we're going to solve those and closing in on today's problem set. So first thing I want to do is just distribute. So I have 3x minus 6 is 8 minus 12x minus 8x. Then I have some like terms I can combine. 3x minus 6 equals 8 minus 20x. I'm going to move all my variables to one side of the equation. And I get 23x minus 6 is 8. Then I'm going to add 6 to each side of the equation and scoop that up here. So I have 23x equals 8, 9, 10, 14. Divide each side by 23. And x is 14/23. And then that does not simplify. So that's my final answer. Okay, next question. Again, we're going to be distributing 1/2 z plus 6 equals 3/2 z. I'm going to do a little side work. So that gives me 18/2, which is 9. Going to subtract 1/2 z from each side. 6 equals 2 halves z plus 9. Now 2 halves is 1. Okay, now I'm going to subtract 9 from each side. And negative 3 equals z, or z equals negative 3. So I'm having a small technical issue. If you would just pause and check your work for that one. Okay, for this one, no values. That would be anything other than 8. Okay, so you want something not equal to 8. All values of x, you want something equal